Hello everybody. In this video, I'm going to show you how to analyze a two-story plane frame. The plane frame consists of the height of the first story is 3 meters. The height of the second story is also 3 meters, which is a regular residential building height of each frame. And it consists of a 5 kilonewton load, lateral load of joints 2 and 3. And you have at the top beam, you have 2 kilonewtons loads acting at a distance of 1 meter and 3 meters from node 3. And in the first story, you have 3 kilonewtons per meter UDL. All the columns are 2I and the beams are I. And the width of the beam, the length of the beam is 4 meters. I value is 45 to 10 power 7 millimeter to the power 4. This is the, and the support conditions is fixed. Let us see how to analyze this using Staad Pro software. Let's go to, as usual, new project plane. This is problem number 8. Usually meters and kilometers should be the units. Next, finish. X000. I will first create the first story, then create the second story. This is Control C, Control V. Y value here is for the first column, it is 3 meters. Okay. Okay. And this is the beam. It is found in the notes. And you can copy this and paste it at x is equal to 4 meters. This is connect these two columns, the first story. Okay. This is the first story model. Then either you can, there are two ways of creating the second story. Either you can copy this and paste it at y is equal to 3 meters. This is one way. Or otherwise, the other way is you can select this. You can go to translational repeat. Translational repeat. If you click on that, this will translate these numbers in any way you want. For example, if you want in x direction, number of steps means if you want this frame to be repeated into another frame, the same frame you want it to repeat only once, then you can give number of steps 1, and this width is 4 meter. You should give the step spacing as 4 meter only. If you give 3 meter, then it will not consider. There will be a problem in the model. Okay, whatever the width is there, you have to give the same width in the x direction. I just show you, this is only to show. Okay, click OK. Now you can see there is another frame form. This is x direction. Okay, but ours is in the y direction. I will undo this. Then select this again, go to translational repeat, y is equal to. While repeating in the y direction, you should also see that the length of the column, whatever the length of the column is there, the same length should be there in the second story also. If it is 2 meters and this is 3 meters, then again the model changes. Okay. So let us give default step spacing as 3 meter because height of the column is 3 meter. Okay. So this is how we form another story. Okay. This completes the geometry. General, next is supports. Create. Support both are fixed. Support. Select the nodes where you want to place the supports. And the supports are created. Next is loading. Go to loads. Load cases, add. None you can as usual give loading. Loading and close. In the loading, you have first nodal loads of 5 kilonewton acting in the positive x-axis. Add that. Then we'll go to member load. There in the first story beam, you have the UDL of 3 kilonewton per meter minus 3 kilonewton per meter in the global y direction. Add. Okay. In the second story, what you have, in the second story beam, you have concentrated forces which are two in number. One is minus 2 kilonewton, which is acting at a distance of 1 meter from the node, starting node. Okay, add this. And you have again 2 meters, which is acting at a distance of 3 meters. Right? I'm sorry, this is to be given minus 2. Since it is acting downward, you add. Close this. These are the only rows. I'll just take this one and just change it to minus. Now we shall add the loads. Consider the node cursor. These two nodes you have 5 kilonewton point lateral load, and at this level you have minus 3 kilonewton UDL, and here at the second story level you have 2 kilonewton load at 1 meters from this point, and at 3 meters you have another point load, and you get the point loads like this. Okay, this is the loading which is considered. Right. Now we'll go to property. Again, go to define general. I value is 0.000045 for beams, and for columns this becomes 9 because it is 2i close. So for the first one, select the beams, assign to the beams. Second one, select columns. See, I have selected this one. If I select this as it is, then the first story beams will get unselected. So for that, you should hold the control button and then drag. The column get selected. This is one way. The other way is go to select beams. Go to select beams parallel to y-axis. So you will select the columns and you can just assign the required I values. This is the properties are to be provided. Then remaining is analysis, perform analysis. Okay, analyze, then analysis. Save. There are no errors. Done. Then, as usual, you can go to bending moments. If you want to see the moments, you can close this. Bending moments. So as usual, hold the control button and scroll the mouse wheel so that you get the magnified image of the bending moment diagram. This you can get as well as FY you can get. Okay. The shear force diagram. Then we can get the axial force diagram also. This is the axial force diagram. Okay. Because of the lateral load, you can see there is more axial load here, as well as the gravity loads. Now, as usual, you can go to post processing. Okay. Then you can just magnify the elastic curve. You can see the elastic curve here because of the lateral loads. You can see there is a lateral movement. Okay, lateral movement, as well as you have the beams deflecting due to the application of the load. Okay, gravity load. And you can see here that again the tangent between these two curves will always be 90 degree. That you should ensure. Here also it is 90 degrees. We have a rigid joint. Rigid joint. Then we can cancel this. You can select bending moment and you can go to results, value, in results, go to bending, as well as you can choose the shear and axial, rotate, those. You can get the bending moment values like this, good, and you can switch off the observed and you can switch on F5 to get the shear force values. Also, you can switch on PFX, you will get the axial force values. Okay. This is how we have to analyze the two-story frame. That's all in this video. Thank you.